Hi everyone, I'm Soumya, a software engineer and an educator. Welcome to module 1 of the project course. In this one, we will be building an exciting application. Sensors in mobile application. It's very unique, interesting and significant topic. In most of the smartphones that we use, we have hardware and software embedded in it. Like the one which is near the front camera, that is the proximity sensor, and the call app, the default phone app that we have, it uses a proximity sensor to make the screen blank when we pick up the call and we put it in this position, because proximity sensor, the role of it is to check if something is very close to it. It senses if any object or any person, anything is very close to the screen of the phone. In the same way, we have multiple sensors in our mobile phones for temperature, for weather sensing, to detect the motion and so much more. Okay, so today I will pick up one of the sensors, which is magnetometer sensor. Okay, and we will use this to make an application which will be very useful for checking the direction, etc. In most of the smartphones there is that compass app by default as well. So we will try to see how to write the code of sensor and how to kind of embed sensor in our mobile application. Okay, so a bit of theory here, then I will get into developing the application directly. Okay, so sensor overview, let's check the official documentation by the Android developers. So this is by Google Android developers, the official documentation. Okay, so this is overview of sensor. Most of the Android power devices have built-in sensor which measure motion, orientation and various environmental condition. Okay, these sensors are capable of providing raw data with very high precision and accuracy, and are very useful if you want to monitor three-dimensional device movement, positioning and so much more. So let me give you quickly few more examples of it, how and where sensors are used. You would have seen, like in some of the games, like if you hold the phone like this horizontally, and you perhaps have to move the car in the game, or snake, something like that, and you move it like this, right or left, you would have seen the car or whatever the device is in that game, whatever the object is, it kind of moves along with the screen. So there as well, the concept of sensor is used in most of the gaming apps, especially sensor is heavily used. Okay, in fitness applications as well, to monitor, to track your number of steps or walk, everything, like a lot many applications are there actually of sensor, because it's embedded in the mobile application, in the mobile phone, and that's why many of the mobile application use the concept of sensor. So broadly, these are the three types: motion sensor, environmental sensor and position sensor. Okay, so motion sensor is mainly used to measure acceleration forces, rotational forces along the three axes. It include accelerometer, gravity sensor, rotational vector sensor and so much more. And there is a lot of like detail provided here, but don't worry, like I know it might take a lot of time and effort to go through this, and it might be a bit difficult if you're especially a beginner. Okay, so I'll make it all very simple for you, and let's start with building our application. Okay, mostly the concept of sensor will remain kind of same across the different types of, like if let's say you are using environment sensor, or maybe motion position sensor, the basic coding part will remain same. You just will need to change the basic functionality what you want to perform with the help of the sensor. Alright, so I'm opening up Android Studio now. If you don't know, so Android Studio is the software which we use to create Android applications. Okay, alright, so here we will open up, we will create a new project. Sorry, not open up, we will create a new project. I'll pick up the empty activity, which is the default activity. Okay, and here I will write what we are going to create. We are going to create compass. Okay, we are going to use magnetometer sensor to create compass application, which will tell us the exact direction. I mean, if I'm sitting here, so it will help me find east, south, where all the directions are, kind of compass application. Okay, okay, compass application, or you can write magnetometer sensor as well. Magnetometer sensor in here. Perfect. All right, and I'm clicking on finish. Let the project get ready. Some Gradle builds, etc. will happen here. So this is our main activity. Let me close the tip of the day, which is Android Studio provides several content project types. Okay, thank you for the tip. And let's close this one. And let me know meanwhile in the comment section which programming languages do you know. I mean Java, C++, Kotlin, whatever programming languages you are comfortable with. Let me know all of those in the comment section below. And I will start with creating the application now. Okay, perfect. Very first thing what I want to do here is I want a compass kind of image, right? And we know that we kind of put all the images in the drawable directory. So I will right click on this and open in Finder. Okay, so inside the drawable folder, what I want to do, I want to keep one compass image. Okay, so compass image, I already have downloaded that. Let me open up a new Finder window and quickly find it in here. So if I search for compass in here and press enter, so compass, this is the image, right? And I will drag and drop it here in my drawable folder. Perfect. And now I will come here in my XML file. I'll remove this and make this as maybe linear layout. Yeah, let's make it linear layout, and orientation is vertical. This also should be linear layout. Perfect. And after that, what I will do, I'll pick image view in here and I will put compass in this. Okay, looks good. And let's make it in the center. Margin top of 100 dp should work. And just below this, I also want to show you that how you can track the degrees with which the compass is kind of rotating itself. Okay, so text view, drag and drop, and in this text view I will show rotation degree. Okay, and this is your text view, this is image view. Looks good to me, and we can put it in the center. Okay, right, rotation degree. Maybe if you want to increase, you can increase the size of this one a bit. 18 dp. Perfect. And now let's come here in the main activity. Okay, when you are dealing with sensors, the very first thing that you need to do is go in the manifest section. Okay, manifest file, and enter the sensor which you are going to use. So uses feature, then name of the sensor. We are dealing with something related to direction and all, so accelerometers should do the work for us. Accelerometer, and also required true. Okay, that's it. And after that, I'll close the manifest file. Now we have to write the main code. We have added the kind of image view, text view, all these things here as well. And now the most significant thing is to write the code here. So while dealing with sensors, we need to implement an interface, that is your sensor listener, sensor event listener. As soon as you will implement this interface, so if you click on this one, control, once again, command enter. So this is how the sensor event listener looks like. This is written in Java. This is an interface. Okay, and it has two methods: on sensor changed and on accuracy changed. So the on sensor changed, as you can see, it's written here. It is called when the accuracy of the registered sensor has changed. Okay, unlike on sensor changed, this is only called when the accuracy value changes, and you can see the sensor status constant, etc. So basically, if we are implementing the interface sensor event listener, then it is giving us some error here in the main activities. It is saying that class main activity is not abstract, does not implement abstract member. Basically it is asking us that, hey Soumya, like you have implemented this interface, so make sure you implement the members as well of this interface. And we just checked that this interface has two methods, two functions, on sensor changed and on accuracy changed. So I will implement both of these. It's gonna be super simple, don't worry. Like I'll be summarizing all of these steps as well, in case you are thinking that it's very tough. No, not at all, don't worry. Okay, so yes, first thing, in the manifest you have to add which sensor you're going to use. Okay, and then you have to implement the interface here, the sensor event listener, and then the overrided methods will be added here. Perfect. Okay, after that the next step is also, like, I kind of have used sensor, so I know kind of what's the flow, how to go about it. But you can also follow the documentation, the official documentation. They would have given the, step by step guidance as well. Like this one is about the environment sensor, and mostly for all of the sensor the process kind of is similar, but here and there their functionalities differ, right? So it is saying to acquire data from the sensor, you first create an instance of the sensor manager class, and which you can use to get an instance of a physical sensor. Then you register a sensor listener in the on resume method. Okay, so first it is asking me to create one object of sensor manager class. Okay, so I have to do this, that I will be creating an object for sensor manager as well as for sensor class both, and we have to initialize that here in the on create method. Okay, here in the on create method. So what I'm going to do here, I'm going to create two variables. One variable will be of type sensor, okay, and the other variable will be of type sensor manager. Sounds good? Okay, let's do it. Sensor variable of type sensor. Okay, sensor, and I'll give it a null value for now, and to handle null exception, this question mark. Then var sensor manager, this will be of type sensor manager, and this as well will have null value. Perfect. And now is the time that I have to initialize both of this, the sensor manager as well as the sensor. So sensor manager, if you see here, they are telling us that sensor manager can be initialized this way: get system service context dot sensor service as sensor manager. Okay, so get system service context dot sensor service as manager. Looks good. This is what they have done, and they're saying get an instance of the sensor service and use that to get an instance of a particular sensor. So first we created sensor manager and we initialized it. Okay, we kind of got the instance of the sensor service, and using this we are creating the sensor. If you see here, pressure variable, this is of type sensor. We named the pressure variable as just sensor in our application. Okay, so using the help of sensor manager, we will initialize this variable now. Okay, we will get the sensor which we are going to use. So sensor is equal to sensor manager dot get default sensor, and after that, like, they have used here the pressure sensor. The type here is pressure. So sensor dot type. So in our case, like, you can see there are so many types of sensor, right? You can see there's a huge kind of variety. We can either use accelerometer, it should do the work for us. So for now I will use the accelerometer sensor only. It is throwing some error that add null, non-null as it call. Okay, to handle null exception, etc. And along with this, because I will be using the image here and the text as well. So quickly let's initialize these as well. Okay, var and compass image, this let's make it late in it. Okay, late in it var, because I don't want to initialize it right now. Image view, and in the same way late in it var, and this is your, you can call it text view, or what exactly it will do for us. It will tell us the degree of rotation, I mean how much the compass is rotating. So rotation TV, that is text view of type text view. Perfect. And here quickly let's initialize these as well. You can use view binding, I have already taught in previous videos. If you want to use, that's kind of new and latest, you can use that as well. But we just have two views, so I'm fine using find view by ID as well. Rotation TV is equal to find view by ID, and r dot id dot the text view. Alright, so we are almost done creating the variables and initializing the variables. So how many variables we created for this? Mainly, if you are going to deal with sensors, you have to create two variables, one of type sensor and the other of type sensor manager, and you have to initialize both of them. It's so easy and smooth to initialize them. And let me tell you another thing, while dealing with direction sensor and such stuff, many people kind of prefer using two types of sensor, but in most of the cases, like the accelerometer, or maybe we have to kind of deal with a bit of orientation. So orientation sensor, either of these will do the work for us. Like yes, either you can use combination of magnet and accelerator, or orientation, both will work fine. For now let's try with type orientation, and I'm pretty much sure it will work fine with us. I'll quickly run the app once everything is done. So we are in between, kind of we have done the most significant part of it. But if you go here in the documentation, you remember that I said, like, while reading you have to register a sensor listener in the on resume method. So in the on resume method, I have to register a sensor listener, and in on pause method, when the application is paused, then in that case I have to unregister the sensor, so it does not occupy unnecessary space, memory, etc. Okay, so on resume method, with the help of this, we will register as listener for the sensor super dot on resume, because it is overrided function, so it's doing that for calling the constructor, etc. And then we have to register with the help of this code, sensor manager dot register listener, this is the function, and then we have to pass three parameters in here. Okay, and in the same way for on pause method, we have to unregister the sensor when the activity is paused, because we don't want unnecessary consumption of our memory, phone memory, etc. Right? So here sensor manager dot unregister listener, you can either like directly use both the methods from here, or you can write it yourself as well. Either way it's fine. So maybe let's try writing these methods on our own. So if you write here on resume, this is the one, right? And we will write here manager, sensor manager dot register listener. We have to register the listener, because if you want to use the sensor in your application, then you have to register it first, right? So very first thing what we will pass here is, we have to firstly pass the context, then the sensor which we have created the variable, and then the sensor manager dot delay normal. So basically context, and then the sensor which we have created. And after that, in the end, command P, if you do, you have to pass this value, which is sensor manager dot sensor delay. They are using sensor delay normal. Okay, sensor delay, and we will put here sensor delay key, sensor delay UI, and normal. Either is fine. Whoops. So this is done now, and after this I will put null safety character here, and then sensor manager, kind of this step which is registering a listener. This is done. Let's write the comment as well, so it will be kind of easy for us to keep a track of which function is doing what operation. Okay, so register a sensor listener for the sensor. This one is done, and now we will call the on pause method. Here sensor manager dot unregister listener, and you just have to pass here the context. That's it. Cool. So the on resume method and the on pause method both are done. The function of basically on pause method is we are kind of unregistering the sensor. If the activity is paused, we want to unregister it. Perfect. So what all we have done till now, we implemented the interface, and we overrided the two methods of the interface, and then we have two variables here, sensor of type sensor and sensor manager of type sensor manager. We initialize both of this here. Okay, and in this one we are using the orientation sensor. If we don't want to use this, we'll need to use two sensors together for the operation which we are going to do right now, which is a kind of mix of accelerometer and magnetometer. Okay, all right, and the sensor changed, accuracy changed, everything looks good to me. Now the most important function is here. When the sensor is getting changed, let's say if you are using the sensor to track the direction, if the value of the direction, if the rotation is happening, if the value is getting changed, what operation you want to perform? So one thing, I want to create a variable here where current degree. Basically this variable will be of type float, and why I'm creating this, to keep track of rotation of the compass, how much the compass is rotating, the degrees with which, the value with which the compass is rotating. So here we have to understand few things. How can we get the value which the sensor is producing? If there is some change, like let's say this is my phone, and if I'm changing the position, I'm kind of moving here and there, so how will this I know that okay, sensor is doing its role, sensor is kind of performing the action in the background, but how do I get that value in my code here? Because I will be able to perform some action only once I'll get the value from the sensor, right? I mean, if I know that okay, the value is kind of, it's rotated by 70 degrees, so east would be in this direction or that direction, so a bit of mathematics is involved here. And let's write the method on sensor changed. So here the very first thing, I want to grasp the value of the sensor. I mean, if I'm rotating the phone, it would be generating some rotation value, degree something, right? So I will create a variable here var degree, and let me show you how you can get the value. So event, it generates value in form of a array, first thing, and we'll get it by accessing the very first index. Okay, let me put here null, and I want to make it round off because the value will be somewhere like in digits, etc. I want to get the round of value, so math dot round, I will use that function. Okay, all right. Now what I have to do, I have the compass image in here, right? This is the image view. So I have to do some animation, I have to perform some animation in this. So compass image dot start animation, right? And in this I have to pass a variable of type animation, right? So I will create a new variable now where animation, okay, or you can say rotation animation, rotation animation, and this one will be I'll use the rotation animation method to write this function. Okay, rotation animation. And if you see here in this, I will be using the fourth type, which it is telling me from degree, from where I want to start to degree. I mean, how much animation, how much rotation I want with this. Okay, so I will start from kind of the initial value 0. I have already created this variable. If you see here, current degree, it is there to keep track of the rotation of the compass only. So I will be starting from 0. Okay, from the current degree. This is the this is the current degree from, and if I do command P, so if you see here, from degrees in float to degrees, how much rotation I want. From 0, I want to go till this value, whatever value the sensor is generating, I want to go till here. Convert this in float to float, and this should be actually negative for the animation to work perfectly. Okay, so minus degree, and this will be in float. Okay, this much is sorted. From degree, I mean initially it's 0, so I will start from 0 degree from to whatever the value this is generating, whatever degrees the sensor is producing. Okay, and what else, if you see here, what value it's asking me for, pivot x type, and then pivot x value, and then again for y the same thing, the type and value. Pivot x type, pivot x value, pivot y type, and pivot y value. It will be same for x and y. Okay, for both the variables we have to use animation dot self, relative to self. This is your type. Okay, and then for the value of pivot x value, let's keep it 0.5f. Okay, and for pivot y type, animation dot relative to self, and same thing for y as well, what we did for x, the same thing for y, 0.5f. Okay, all right, so this much looks good to me. Now I will pass here the rotation animation. Okay, and a few things extra what we can add duration, rotation animation dot duration. What will be the duration of this animation? It can be around something 210 or so. And let's see what other parameters are there. Fill after, fill before. Okay, let's keep true. All right, so we have degrees to get how much rotation is happening. Okay, and because we have to do some animation in the compass image, so we used compass image dot start animation, and then we pass this variable rotation animation. And for rotation animation, I'm giving all the information to this method. You have to start from current degree, from 0 till whatever the value it is producing. Okay, and then I am passing the values of pivot x and pivot y, basically x and y, the axis, the orientation, it is for all of those. Okay, And duration, I have given it the value 210. You can give it according to your preference. And then we have fill after. So that's pretty much it about the on sensor change method. And one more quick thing, current degrees as well. Like we kind of created it here in the beginning, right? And after every spin animation, or you call it rotation, the value will be changed, right? So I want to update its value as well. It should be equal to this one exactly. It should always be, by the end of this, it should get equal to this value. Okay, to float, sorry. Yep. All right. So that every time, like I started from 0, I did the animation till here. Then again, I have to start from here now. So from degrees should be equal to the last value. Okay. It's a bit of mathematics. I'll get into the iPad to explain. But let's first check if the application is working fine. Let me see if I'm missing something. So for sensor, we added the sensor event listener, and we have the two methods, overridden methods. Because of that interface, we have two variables. We initialized both of them. It looks good to me. And okay, another thing, in this text rotation TV, I didn't add the value, right? So rotation TV dot set text is equal to degree. Show the degrees, right? Degree dot to string plus degrees, something like this. Okay. So it now looks perfect to me. Let's run in the app, in the phone, in the smartphone, and check if it's working. So in the emulator, it might not work very well. So I'll bring my phone now and then we'll run. So I've connected the smartphone, the Android phone here. I will click on run and the application is getting prepared. Let me go in the project. I think I'll need to make one change that in the module section. Let's change the compile SDK and target SDK to 34. It's making the same complaint, sync now. And after that, build is successful. And I will go in here. This is the smartphone. Okay, I've connected it and we are running it via Visor. This is the phone. I hope you can see the app screen. Okay, so we'll click on install now. Install. And this is the compass app. As you can see, if I'm rotating it, right, like this, so exactly like east, for me east is this one, this is north. It's just telling me the correct direction. And degrees as well, as you can see, it's changing so fastly. 340 degree, 58 degree. If we go here in the, in our Android Studio as well, and in the log cat, I think we have not logged that. You can check the values, the rapidly changing values, by logging as well. Like if you go in here, the you can do something like log D and press enter. And here you can ask for the values of, maybe just write degree here. Okay, I want to keep track of the values which are getting changed here. And for that, we need to do option enter. That's it. Once again. Perfect. All right. So this is how the app looks like. It's blank right now. So I think it's working completely fine. Okay. The application is all good and set. So I hope you got a bit of idea like how to go about it, how to write the code of sensors. Okay, we used one sensor in this one. I will try to cover different types of. So as you can see, like the orientation sensor, it worked for us, right? Or we could have used a combination of two sensor as well. but this one is fine. And in manifest you just need to write the sensor name which you are using. So I hope the concept is clear. Let's quickly get into the iPad where I'll be explaining quickly like what the summary, what all we did. Okay, so the very first thing, we need to implement this interface sensor event listener, right? And with the help of this, we got two methods, two overrided method, that is on sensor changed and on accuracy changed, right? So that is the first thing. And then we have to create two variables, sensor and sensor manager, of type sensor and sensor manager, right? And we initialized both of this here, like with the help of get system service method, and then sensor, with the help of sensor manager we initialized sensor. Perfect. These were the images etc that we used. Then in on resume method we have to register a listener for the sensor. It's very simple. And then in on pause we have to unregister the sensor with the help of unregister listener method. And the most significant one is on sensor changed method, where we performed all the operation what we have to do. We basically wanted to run animation, right? So compass image dot start animation, and this is the value of the animation. Now this part is very important. It's all about kind of mathematics. We got the value from the sensor, like whatever is the change in the degrees and the rotation direction, everything we got the value with the help of this event. This is the event dot values dot get, and at 0th index, every time in all type of sensor you will get the value in form of arrays, and at the first like 0th index you will get the values. Okay, whatever the sensor, whatever value the sensor is producing, you will get all of that in the first index, which is like 0th index mathematically, technically, right? Perfect. And we did round off of this value. So math dot round, this is the degree with which the kind of phone or the sensor is feeling that okay, the sensor is sensing that this much rotation is happening. So after that we showed the same thing in the text view. And this is the rotation animation. We created the variable with the help of rotation animation method, in which we said from this degree to this degree this much rotation will happen, and we pass the value for pivot x and pivot y. Okay, and we added duration etc for the animation, and we also updated the value of current degree variable which we created in the beginning every time. Okay, every time. So this is the on sensor changed method. You can take a screenshot of this if you want, and this is the complete code that we wrote for the compass application. And apart from that, we also have to write the name of the sensor which we are using in the manifest file. So yes, let me know in the comment section below if the concept is very clear to you. Maybe just write understood or completed the project or understood the concept whatsoever. Just keep me posted how you are feeling about all of this tutorial, and tell me which tutorial you want to see next. Welcome to module 4 of the project course. The fitness app and sensors. Fitness app and sensors. So in this one, I will be making an application which will be related to health, fitness app. Okay, and there we will see in the like health industry how we can utilize the concept of sensor. So basically there are a wide variety of application of sensor in the health industry, but we'll focus on a few of them. Okay, so I will be making a health application, a kind of something which those health related the beginner companies etc also want to have. Like when I was in like university, I created an application, a health application for one of the gyms where I used to visit. There were like basic feature what they wanted to do. Like they wanted to include all the basic stuff in the app, in that Android app. And for advanced thing, they wanted to kind of market their gym membership. They were like, okay, like these are the things which you can, these are the exercises you can follow daily on daily basis for better health etc. And like if you want like trainers to train you and all of that, then come to our gym, or our trainers can visit at your home as well. So sort of an application that will give something free of cost. Then like on top of that, if they want premium stuff, then they can pay for it. That was kind of application, and that was a good idea. Like I liked it. I mean, the founders etc of that health company, they were quite happy with the results as well. So it will be on similar ground, I would say. uh, we will be building health application which will include all the basic features. So what idea is coming in my mind, let me show you. So if this is the screen of the app, like we can have the logo of the app, right? That will be the splash screen, and then we'll move on to the main screen where we'll give a lot of options to our users. Now to give options, you can use any of the methods out there. Like here you can use this space to show banners etc. Then you can have card views to show different features. Okay, for now I don't have like banners etc, I don't want any such stuff, but the application that I created, it was like that only. If they have some Black Friday sale or Diwali offer, anything like that, so we used to kind of show those stuff there. Okay, so they created a specific logo as well, particularly for this application. And you can create as per your wish for this project, which we'll be just doing now. I'll use a sample icon from the web. Okay, all right, so I'll create some card views here. Okay, I'll create 4 card views here. One of these will be to measure your body mass index. The other will be about your the entire day, how much steps you took, and how much calories you burn, based on that, all those stuff. Okay, here we'll use sensors. Okay, sensors is specifically pedometer kind of. Okay, pedometer kind of. And then here you can show some generic tips etc, which, I mean, for this they had this section as well, but these were specifically curated by their health experts. So if you are not an health expert, you are creating just for the sake of learning, you can include stuff from the internet, right? Health tips, exercising tips, whatsoever. And then I will be including one yoga section, and if you go in here, then you can practice stuff like meditation and all those things. Okay, so this is kind of basic idea. We have 4 card views in here, 4 features. Let's see how much we are able to complete in this tutorial, because we have a time frame as well in which we have to complete this project. So all right, let's get started. Let's start with BMI, then we'll do the sensor thingy. If these 2 will be done, that will also be great, and the other ones I would love to see from your end, but let's see how much you are able to complete. Let's quickly get into the system, and I will create a new project here in Android Studio. So Android Studio, we are opening it up. Let's create a new project from here. Okay, empty activity, right? And my application, let's name it fitness sensor, fitness and sensor. And there are many other ways as well where sensors can be used in your application, in your health application specifically. We'll see one use case of this, like if you have to use steps, if you have to measure steps etc, how you can go about it. Okay, all right, so the project is loading, and I first have to create this splash, right? A splash activity. So I'll use the main activity only to make the first screen, and then we can have like home screen etc, where we will have multiple card views. Okay, so let's come here in the split section, and I will remove this constraint layout. I'll make it linear layout. Okay, and orientation is vertical here. Orientation is vertical. Remove this text view. We don't need any kind of text view here. In the splash screen, what are the main things that I need logo, right? So logo I have downloaded from Undraw. Okay, let me show you how you can do it. So open in Finder. This is drawable. So if you go here on Undraw website, you will get a plenty of option. First thing, you can customize the color based on your app's theme. So before getting into coding, if you are making the app for your client, so you have to sit and decide the theme with them. You have to send some design proposal, design options to the client. Whatever they approve, whatever they like, you have to do things accordingly, right? So like this client, the gym client which I had, they had no clue of design, etc. So they were like, you do it as per your intelligence, and they liked it. I mean, sometimes it happened that you create design, etc. on your own, and then they're like, oh, this is not good, change it. It happens specifically with Indian clients a lot. So here we have this yellow color. If you have to make some health related app, you can search like health. So a lot many options are here. Stability ball, etc. The default color is also good actually, which they have. Jogging and so much. Okay, so I have downloaded from here only. These are the logos which I will be using in our application. So let me put all of this into our drawable. Okay, all right, we have added, I think, all of these. Logo is left. So logo fitness.png. Now I'll come into the design section, image view, drag and drop, and I want to use logo fit. Okay, cool. Let's reduce the size, etc. for this one, because logo should be small, cute and precise. So 200 dp, let's put it in here in the center, margin top as 200 dp. Cool, looks good to me. And now I'll write the code quickly for splash here. That's very easy. First thing, in this splash screen, you don't want action bar. Okay, support action bar dot hide null safety here, null safety. And after this, I have to open up the new screen. So for that, what I will do, I have to use post delayed method of handler dot post delayed. One second, handler dot post delayed. Inside this, I will use looper, which is not deprecated, looper dot get main looper. And here, if you see command P, so you have to pass two things, runnable and delay in millisecond. So delay, I want 3000 millisecond. Okay, the splash screen should ideally last for 3000 millisecond. And here I have to open up a new screen, right? So I'll write the code for intent. Well, I is equal to intent. Oops. One second. Oh, sorry. I have to put all of this in. It's runnable, right? So I have to put it in double quotes. And yes, let me do it like this. Val I is equal to, God, so many typos happening today. Intent, this context, and then the name of the activity which I want to open up, then start activity and intent here. Okay, so it looks good to me. Make it like this. I have to write the name of the next activity. So let's create the new activity. I will name it empty activity. Here it is. I'll call it card activity, because we'll have a lot of cards here, right? Card activity, and finish. I'll go in the main activity. I will say, hey, I want to open up the card activity. Class.java. Start activity I. Oops, no, this one. So it looks good to me. We have the support action bar here. We have given the instruction that hide the support action bar. We have handler dot post delayed. Post delayed is very significant method here. And we are using looper dot get main looper. This is not deprecated. And yes, I mean, we are opening up the new page after 3000 millisecond, closing the main activity now. The work is done. Now here is the interesting part. Activity card. Here we will be using constraint layout only, because if I sit and write linear layout code for so many cards, it will be like a lot of work, right? So I'll use constraint only. So card view and drag and drop this. So in here what I'll do, I'll give some specific height and width to my card views. Okay, 200 dp. Let's maybe make the width as 150 because we want 2 cards to be there, right? I want it to be here. Let's constraint it, not 52. Let's keep 32 standard for all the cards. Okay, 32 sorted. And after this, I want the other card view in here. For this one as well, I want the height to be 200 dp and I want the width to be 150 dp and constraint it as 32 dp here. Okay, width should be 150 dp. Okay, and after this, constraint, this one should be 32, this also 32. Perfect. So both of these are constraint, 2 cards are constraint for us. Okay, all right, now I will bring the third card, which is for health tips, right? So here as well, width 150 dp and height 200 dp. Awesome. And after that, I have to constrain this one as well, right? So this side 32 dp, same as the above cards, and just below this 32 again. It's interesting to do all of this. If you are using constraint layout, no, make sure you are using best out of this section, the attribute section. It's so easy and handy. Things become very easy actually. So here we go, and maybe it might happen that these cards are going too down, right? So I'll make it somewhere as 100 dp maybe. Okay, for both the cards which will be here. All right, and after this, let's constraint it like this and bring it back to 100 dp. Cool, awesome. And the last card view that I want is for the yoga section. I will put here 150 dp and it should be 200 dps. Okay. I mean, this is the reason, why I don't do too much of constraint layout in the live when I'm teaching live. Okay, I mean, it takes so much of time that we miss on the logic part, right? Okay, 100 dp. Cool, and I'll constraint it like this and be here with the third card view. Looks perfect to me. And now what I will do, let's give some corner radius to all of this. Card corner radius and 10 dp should look good. If you see here a bit of corner, like if you see here on the first one, there is corner radius thingy. Others are very sharp, right? So let's provide it to all of these. Card corner radius, and for this one as well, card corner radius 10 dp, and for the last one as well, quickly. And now what I will do is I will put images in all of these. Okay, so image view for the first one, we want BMI, right? So this is the BMI image. Awesome, looks perfect. The second one, we created the card view for in the iPad. What we decided to have, perometer sort of thing, sensor, right? So we will put this logo in there. And then for the third one, what do I want? For the third one, I want tips, health tips. So this one. And finally, for the fourth one, yoga, I have this yoga logo. It looks so good to me, and now I will move in here. For all of these, I will give meaningful names. IMG BMI, okay, image view BMI, and this is IMG image pedometer, and let's code for these two first, and then we'll see what to do about others. So here is the code for card activity. We don't need to do too much on this. We just have to open up new screens specifically for BMI and pedometer. So let's create quickly two more activities here. One activity will be for, where is your empty activity here? One activity will be for BMI, right? So we will create BMI activity. BMI activity, and I want a layout file as well. So it should be activity BMI. That's it. And click on finish. Along the same line, I want activity, empty activity, and here for the second card, right, which is pedometer. So activity pedometer is the right name for the XML. And let's go. One second. Pedometer, pedo sensor. Makes sense? Okay. Cool. Let's click on finish. And the card activity, let me write the code for all of this quickly. So val BMI is equal to find view by ID here. That is image view, right? Image view, the BMI one, r.id dot BMI image view, and then val after BMI I have the sensor thingy, right? So pedometer basically. Sensor is equal to find view by ID. Find view by ID, and here I have to give the image view r.id dot image IMG pedometer. Perfect. So on clicking the image view BMI, BMI dot set on click list. Now what do I want to do? I want to open up a new screen simply, right? So val I is equal to intent, no, not internal error. Okay, intent, and here I will pass this. And what's the next page which I want to open when someone clicks on BMI card? I want to open up the BMI screen, which is my BMI activity class.java, and start activity and pass I in here. Awesome. And similarly, I will be like on clicking sensor card view, what you want to do? You want to do similar thing. You want to open up new page, this, and then you have to open up the sensor class, sensor activity, pedo sensor. The name is pedo sensor, and class.java, start activity, and I hope this much part is clear. You can call it I2 just in case there is shadow or anything like that. Looks good to me. Let's run till now and see how it is. I'll hide the support action bar because I don't like seeing action bar too much, especially if your theme is the default theme. Alright, so let's minimize this, and I'll quickly write the BMI code first, okay, and then we'll jump on to the pedo sensor thingy. Oh god, let me update this. I should make it a habit to use upper API levels, otherwise it will always be like this. 34, it's asking me that, hey Soumya, please update your API level. Oh, whoops, sync now. I had to do sync now as well. Once this will be done, I will write the code here in BMI. So in BMI, I will need two input from the user, which is the height and weight, and then I will calculate BMI. There are very interesting, websites for this, for BMI calculation. I was checking one of the website, and it was too good actually. Let me show you quickly where that is. 1 second. So this one actually, body mass index calculator for adults, or you have to give your height in centimeters. So we will take the same input from user, we will ask for height in centimeter and weight in kgs, and then I'll press on calculate. So this is the value. If the value will be under 18.5, that means the user is very underweight, and if it's between this, so it's healthy, otherwise overweight. So you can do like I am planning to show just the BMI value. After that, you can be like, if the BMI value is less than 18.5, then you can show some animation, or they show some sort of a graph, whatever you want. You can show whatever is good for your user. So card, everything looks good to me in here. In the beginning, like at the top, you can write welcome to health app or something like that. We would have obviously missed the splash screen that only lasts for 3000 millisecond, but when I'll run it again, so I'll show you. Now let's close activity card, all of this, and I just want to focus right now on the BMI screen. So here I'll make it linear layout because I want everything vertically, one after another, and orientation should be vertical. Okay, let's change this to linear layout. So how much data we want from user? We want one plain text in here. This will be for your height in centimeters, right? And there will be another, first let's check this one. Edit text, height. Okay, remove this unnecessary stuff. I don't want any of these. You can give a hint to the user here. Enter height in centimeter. Okay, in cm. Enter height in centimeter, and give margin to this view, margin 20 dp. And after that, I'll just copy and paste this one for weight in kgs. Et weight, oops. Et weight, and enter weight in, not centimeter, in kgs, in kg, in centimeter height, and enter weight in kg. After that, I will show a button. Which will say calculate BMI. Calculate BMI. This will be BTN calculate, or maybe BTN BMI also makes sense, right? So BTN not capital, come on. BTN BMI. Calculate BMI. You can make it wrap content, and then give the gravity center and all. Okay. So this is done, BTN BMI, and where will I show the value of the BMI? Let's simply put a text view in here. Okay. So here I will show. Let's make the gravity first as center. Cool. Text size bold. Let's make this style bold, and text size, because it should look, I want the result to be highlighted, so I want this to be bigger. Okay. Margin as 30 dp. Looks good. And this is result. We are calculating BMI, so TV result. Okay. Oops. Looks good to me. Till now everything is sorted. Now let's quickly write the logic to calculate your BMI. Okay, so val, what all we have in the activity. I have height, weight, button, and text view. So 4 views are needed. Cool. Val height is equal to find view by ID. This is your edit text, and r.id dot et height. Val weight is equal to find view by ID edit text, and r.id dot weight Awesome. And now I have height, weight. I want BTN calc. BTN calc. Nice. Shortcut. Find view by ID. And here I will write edit text r.id dot BTN BMI, right? BTN BMI. Let me verify the name of this button. Yes, BTN BMI. And then finally the text view val result is equal to find view by ID result TV result text. Find view by, this is text view. This is text view and r.id dot result TV result. Okay, perfect. Now I'll calculate the BMI. So when the user will click on this button set BTN calc, so set on click listen, set on click listener. So whatever action I want to perform, I'll write here. And this is, come on, not edit text, this is my button, right? So when the user will press on this button calculate BMI, I want to get all these values first quickly, like height, weight and everything, and then I'll convert and use the formula to show the result. Make sense? So val h, that is height, is equal to height dot get text dot to string. I have to convert all of these to float actually. And one more quick thing, because this let me show you on iPad so that you don't feel that I'm missing something. So the formula to calculate BMI is, BMI is equal to weight in kgs divided by height in meter, height square actually in meters. Okay, all right. So I'm getting the values in centimeters, right? So 100 centimeter has 1 meter, so 1 centimeter will have 1 by 100, that is 0.01 meter. So I'm getting the value in centimeters. So if the height is 159 centimeters, so it will be 1.59 meters, right? Basically I have to divide the value by 100, so I get it in meters, right? So I get it in meters. So I will do the same thing here. I converted this in float and now I will divide this by 100. Okay, so height is sorted. I got the height in meters. Now weight, W, is equal to weight dot get text, no, not x, weight dot text dot to string, and all of this in float. Let's convert all of this in float. So dot to float. Looks perfect. And now I will calculate result, which is R variable, which will be in R variable. So val R is equal to W divided by weight divided by height into height into height. So looks good. I think I should have the right result in this variable. So now what I will do is result text dot set text is equal to R. Or 1 second, you can be like your BMI is, and then I'll put the R variable. Okay, let's run it and see if it's working fine or not. Okay, I think it should work fine. We calculated the height. So whatever the user will enter here, 1 second, whatever the user will enter in the edit text, I'm getting the height, I'm getting the weight, and then using the right formula, and then I'm like result text dot text, set text is equal to BMI. So let's open it up. Nice. So height 159. I am not sure actually, but I think it's 159. Enter weight in kgs. I'm entering 60 again. I'm not sure. Calculate BMI. So your BMI is 23. My BMI is 23.7. So if you see the data on this sheet, so 23 meaning I have healthy weight. Nice. So then like you can put condition, if else, if BMI is this, then show this, or otherwise show that, right? You can do those stuff. All right, so we have implemented one feature of the app. That's cool. Now let's focus on the other one, which is your pedometer sensor thingy, right? Now for the pedo sensor, what I will do is I will use this circular progress bar. Okay, like I will show here some sort of animation. I will show like circle progress bar, and as you will move, as a you will walk, it will show the number count inside the circle, and at the same time some animation will go there outside the boundaries of the circle to show how many steps you are counting, sort of. Okay, all right. So I will use this one. For this I have added the implementation. I have added this third party dependency in my build.gradle. Okay, and in my build.gradle, and it might happen sometimes the third party dependency that we use, they might be not compatible with Android X, right? So for that matter, let's enable Jettifier. You have to add this enable Jettifier true in your Gradle properties. Let me show you where exactly. So Gradle properties here at the bottom. So sometimes if you are using animation or such related third party dependency for any matter, and that's like old or something like that, make sure you are including this. It will automatically convert all of them into it will kind of make the third party dependency compatible with your application. Okay, so I'll put here the progress bar, and it's showing me error. What's saying the view is not constrained. Okay, I'll constrain it, don't worry. So like to constrain as well, I should have some data, right? So maybe I will, if I use linear here, linear layout, it's sorted. Nice. I am not able to see anything in the design, so I will invalidate cache. Maybe I'm writing code since long and it's not able to process, etc. So I will quickly invalidate cache and get back to you in a short while. Okay, so I invalidated the cache, and here I can see the circular progress bar. What I will do is I want the width to be 15 dp. I want it to be a bit more thick from the outside, so 20 dp. Okay, and let's maybe use constraint only, and I will constraint it myself. Okay, so let's go here in the design section, and I want to make it a bit small in size, and I want to keep it in the center. So here we will constraint it to 200 dps on all sides. Okay, and 100 maybe from the horizontally. So let me do one thing. I also want two text views here inside the circular progress bar. So I'll put all of this in here. Okay, I'll constraint it and we'll come back and show you how the final one looks. Otherwise the recording will be too long if I'll sit and constrain it all while doing the recording. Well, it's easy, it's not difficult. I'll constrain it this side, and for this one like up across the boundaries of the circle progress bar. Okay, so I have constrained the circle progress bar and also these text views, and this is how it looks like, the final thing. Okay, and I have to show the number of steps per 2500 steps. That's why I have used this text view for constant value. Now I will come here and pedo sensor. For sensors, first thing you have to add a lot of things here. Whatever you will use, you have to add all of that. Uses feature, name of the sensor. So I will use the step detected, step counter required true. Okay, required true. quickly adding all of this. Uses feature again, uses feature, name is step, directory is already there, so step counter now, and required true, okay, required as true. And finally after this, what I want uses feature, name should be I want accelerometer, yeah, accelerometer, and required true, and just close it. And last but not the least, we have permissions also. So whenever you are dealing with a step sensor, no step counter, etc., make sure you add the activity recognition, this permission, okay. I'll close it. Looks good now. And for sensor, the steps will be very much similar to what we have been writing over tutorial 1 and 2 in this series of applications, okay. You can find the detailed guide, the tutorial on sensors overview page. Steps are very simple and straightforward actually. So I'll create val sensor of type sensor, okay, and I'll give it the value null. I have explained in detail all these steps in previous, I have explained all these steps in detail in the previous tutorials, so I will be not going too much in detail, okay. Make sure you have watched all of that to clear the basics of sensors, okay. I will now initialize these here. Sensor manager is equal to 1 second, get sensor, get system, get system service. You can find all of this here. See, sensor overview, motions, so many sensors are there. All of them are more or less same, the execution part. So we have to create sensor, we have to create sensor manager, then we have to initialize it. That's what we are doing, okay. And then we will be registering the listener for the sensor using on resume method, okay. Context dot sensor service as sensor manager, cool. And now what error is it throwing? Val cannot be reassigned, oh sorry, var, and this should also be var. Now sensor is equal to sensor manager dot get default sensor, and here we have to pass the type of sensor which we'll use. So here they are using pressure sensor, and we have to use sensor dot step type step counter, okay, step counter, and null handling done. After that we also have to use sensor event listener, right. Sensor event listener, it provides us with two methods, that is on sensor changed and on sensor on accuracy changed, okay. In the on resume method, I will quickly write the on resume method, and I will register my sensor here. Before that I will check if the sensor is null, because in emulator you can't have the step sensor, right. So if it's null, then show a toast dot make text this, and sensor not found or sensor not present, sensor not found, and toast dot length short dot show dot show. Otherwise if the sensor is present, and in many of the phones as well, in the smartphones, if you are running in your Android device, in many of the Android devices as well, the step sensor is not present, especially in the old ones and new ones as well, like you need to check, okay. After that I'll register the sensor, okay. If you see here on resume, we use it to register a listener for the sensor, so we will quickly do it in here. Sensor manager dot register listener, this context we will pass the sensor here, and then this is there to delay the service, like there is not too much of fast UI change, etc. Now on sensor changed, when the sensor is getting changed, I want to name it as event, okay. So I will get the value. I have explained to you that we get the value from sensors in form of arrays, and that too at the 0th index. So val steps val steps is equal to event dot values, and we want it from the 0th index. So this is the value. Okay, now I have to set this value in my text, in my TV steps taken. So I'll create here var steps is equal to find view by id, text view, whoops, not text view, and r dot id dot TV steps taken, and steps dot set text is equal to, okay, we have so many variables with the same name, steps taken, let's name it this way, and that's it. We have to change it to toString, I guess. So that's it. We created two variables, we initialized them, we registered the sensor list in the on resume method, and on sensor change we are getting the value of steps etc. here, and then we are setting in the text. So let's run it quickly and see how it is. Okay, so it should work fine. I mean, to understand in deep about the sensors, you can revisit my light sensor tutorial, and the other one was also magnetometer sensor something. So go ahead and check those tutorials, that will help you go in deep into the sensor topic. Okay, so let's wait for this to run. I hope the concepts are like more or less clear. If you have something in mind or you're facing error, just put them in the comment. So this is splash screen. Okay, these are the cards. I want you to complete the tips and the yoga part. Okay, complete it and put it on the internet, LinkedIn, Twitter, everywhere. Tag me Scalar, so that either me or someone from Scalar, mentors from Scalar, can review your project. So BMI, we have already checked the functionality of BMI part. It was working fine. For perometer sensor, sensor not in emulator, sensor not found, it is showing. You can check in any Android device where the sensor is working, but the code is like it's good to go. Like we have earlier seen for the light sensor etc, we were getting values, right? So in the same way you will get values for the steps covered etc. So that's pretty much it about this tutorial. Complete the project, push it on GitHub. I'll push it on GitHub so that you can check it out, especially for the logos, pictures, whatever I use, design, if you want to use anything. And yeah, that's pretty much it. Complete it and tell me. Okay, I hope you liked the tutorial. If yes, make sure you hit the like button and subscribe to our channel for more such insightful content.